A team from Hole Oceanographic Institution will be among the first in the water after the SS United States is deployed as an artificial reef off the coast of Destin Fault Walton Beach, launching a long-term study to track how an entirely new ecosystem takes shape from the moment the 990-foot vessel reaches the seafloor. The research vessel, led by the Hole Oceanographic Institute scientist Dr. Kristen Meyer-Kaiser, represents what she describes as a once-in-a-career opportunity. There are roughly 3 million shipwrecks worldwide, but scientists almost never get to study one from the very beginning. Every time a ship sinks, it is a brand new habitat falling out of the sky, Meyer-Kaiser said. Usually, when we do research on those, we find them years, decades, maybe even centuries after they have arrived on a sea floor to get the information. So in order to understand how we observe the wreck, there's a lot of interpolation. There's a lot of guesswork. The SS United States deployment changes that. Meyer-Kaiser and her team will establish what she calls a true baseline. Not the ecosystem as they found it, but the ecosystem as it began. This is going to be the first time that anyone's going to be able to do this on a scale of a large vessel such as the SS United States. To be there right from day one at the sinking, she said. It's an incredible opportunity. Meyer-Kaiser has developed a schematic of approximately 132 permanently tagged locations across the vessel. She provided Okaloosa County Natural Resources Chief Alex Fogg with cattle tags during a visit to the ship in Mobile, Alabama back in December, with instructions to mark those locations before development so researchers can return to the exact same spots over time and document the changes. The research structured around 3 interconnected areas of study, what Meyer-Kaiser describes as 3 verticals of a triangle: water chemistry, microbiology, and invertebrate communities. We'll collect water samples and see what the ship is contributing to the surrounding water layer, she said. The microbes that are living on the ship itself and maybe contributing to chemical changes like redox reactions. And then we'll have photos and settlement panels to track what is settling on a ship over time. And if there's coral arriving, if there's sponges, if there are sea fans. The goal is to understand how these 3 elements influence one another collectively and how they shape the reef ecosystem. The field work will require technical scuba diving at depths reaching 55 meters or about 180 feet at the sand line. Meyer-Kaiser, a closed-circuit rebreather diver herself, will lead 2-person teams working the deeper portions of the wreck, sampling at tagged points at 55, 45, and 35 meters. The dive plan approved by Hole Oceanographic Institute Dive Control Board allows 13 minutes at each depth while keeping required decompression stops under 30 minutes at 20 feet, with a total run time of approximately 90 minutes. A second team, led by Fogg, will operate at shallower depths between 20 and 25 meters, collecting the same types of samples from the upper portions of the vessel. Alex and I both know pretty clearly what's going to go on here, Meyer-Kaiser said, so we can be the leaders of those 2 dive teams, divide and conquer. The team plans to begin sampling within a week or 2 of deployment, allowing the initial surge of recreational diving interest to settle before research operations begin. One of the central questions is how quickly microbial biofilm will form on the ship's surface, and what happens next. Microbes are everywhere. They're probably going to be the first thing to colonize the wreck, Meyer-Kaiser said. Based on comparable studies using metal test discs placed on artificial reefs, she expects biofilm to develop within weeks or months. That biofilm matters because it produces chemical cues that influence which invertebrate larvae drifting through the water in search of a suitable habitat will settle on the structure. When invertebrate larvae are drifting along in the ocean, dispersing to their new habitat, they're smelling the water, and they're looking for chemical cues to indicate that this is a good place to live, Meyer-Kaiser said. So how that biofilm takes shape influences what is going to settle there in the terms of the sponges, the corals, and the anemones. She expects the reef to eventually support gorgonian sea fans, soft corals, and other filter-feeding organisms, particularly on the upper portions of the wreck where the currents are stronger. Meyer-Kaiser compared it to the conveyor belt, sushi restaurant. Organisms that can position themselves higher on a structure are exposed to faster-moving water, bringing more food past them per units of time. When you get a massive shipwreck like the SS United States, those upper portions are going to be exposed to really swift currents. She said, I anticipate that we're going to have a lot of things wanting to live in the upper portions of the wreck because there's a lot of food for them there. The vessel's unusual construction, a steel hull paired with aluminum decking and superstructure components, gives researchers a built-in comparative study that most artificial reefs can't offer. Iron from the steel hull plays a role in photosynthesis, and some research suggests it may help corals withstand higher temperature waters. Though too much iron can become stressful, Meyer-Kaiser compared it to taking multivitamins, beneficial with a certain range but potentially harmful in excess. There is some experiments showing that when corals live in iron-rich waters, they were able to withstand higher temperatures better, she said. Aluminum, by contrast, has no known biological function and can stress organisms at relatively low concentrations. Meyer-Kaiser said there has been a paper currently in press comparing World War II-era iron shipwrecks with the aluminum airplane in the tropical Pacific. The iron vessels supported dense, diverse coral communities while the aluminum aircraft was sparsely colonized. This is a chance to look at that within a single vessel and really dial into that physiology and the chemistry to try to understand the impact of those metals on the organisms that are going to live on the SS United States, she said. The team's chemical monitoring will also include tracking how metals from the vessel's coatings and structures behave in the surrounding water columns over time. That includes monitoring chromium speciation, a topic which has drawn public attention due to the zinc chromate primer coatings applied to the ship during its original construction in the early 1950s. Meyer-Kaiser said her team plans to include chromium in its chemistry analysis as part of the broader research into how the ship's materials interact with the developing ecosystem. Okaloosa County is following all regulatory guidelines outlined by the EPA, Army Corps of Engineers, and other regulatory agencies based on county documents. In addition, all peeling and exfoliating paint have been removed during the remediation process in Mobile, Alabama. The SS United States project advances what Meyer-Kaiser and collaborators have termed maritime heritage ecology, an interdisciplinary field combining marine biology and maritime archaeology to understand the role shipwrecks play in ocean environments. Meyer-Kaiser co-developed the field with archaeologist Calvin Meyer after the two worked together on shipwrecks in Stellwagen Bank National Marine Sanctuary off Massachusetts in 2019. We had this collective light bulb that there was a dramatic need for biological, archaeological, and collaborations to really understand the role that shipwrecks play in the ocean environment. There is an indelible human footprint on the sea floor that is only increasing over time. The core thesis, biological change on a shipwreck, is coupled with the physical and chemical changes to the wreck itself. On wooden shipwrecks, for example, the arrival of the shipworm leads to structural degradation over time. On the SS United States, that coupling is expected to center on a vessel's chemistry. Beyond the core research, Meyer-Kaiser envisions the SS United States eventually serving as a platform for permanent ocean sensing equipment such as temperature and salinity sensors and underwater cameras. She also hopes to develop a citizen science program that would enlist recreational divers as monitors. Suppose you want to put energy infrastructure in the ocean. Something is going in anyway, but you want to make it a positive impact on biodiversity. Learning what we can do and learn from shipwrecks and from artificial reefs will inform better design of built infrastructure so that we can actually have a net positive impact on the ocean biodiversity. She called it nature positive design. She said lessons learned from the SS United States could shape how humans build in the ocean for decades to come. For Meyer-Kaiser, the project is also deeply personal. She first learned about the SS United States deployment at the Hole Oceanographic Institute's donor event, where a supporter noticed her research poster on shipwreck ecology and mentioned the project. She immediately reached out to Okaloosa County and worked her way to FOG, driven by what she calls a once-in-a-career chance to understand an ecosystem from the very beginning. We're going to be able to answer a lot of really cool maritime heritage ecology questions with the multidisciplinary data that we can get from the ship, Meyer-Kaiser said. It's going to be phenomenal.